Hello students, let us start today one more important topic of our modern physics, that is photoelectric effect. Try to understand that photoelectric effect is simple chapter, but the questions from photoelectric effect are very important, and little bit of your concentration together with the understanding of the concept certainly will prove a worthwhile investment which will make you capable in solving any problem from photoelectric effect. So the topic of our discussion is photoelectric effect. Photo is related with light. Photoelectric effect is explained on the basis of modern theory, that is particle nature of light. Newton gave the corpuscular theory, but the particle of Newton was different from the particle that we call as photon. Photoelectric effect, basically photon theory is used to explain this effect, and it is very successful in explaining this effect with the help of photoelectric effect, and where the classical theory fails to explain the photoelectric effect. What is classical theory? Electromagnetic wave theory. On the basis of electromagnetic wave theory, we cannot explain the photoelectric effect. Now, photon, as the energy of photon is h nu or hf. This is the energy of photon. Now, what is important to understand? H is your Planck's constant. You should understand it very carefully that some introductory information might have been given to you in the chemistry class of standard 11th, where photoelectric effect is also discussed. This Planck's constant has the value This Planck's constant has the value 6.62 into 10 to the power minus 34 joule second, and F represents your frequency, or nu you can say. This is the energy of a single photon. Now, photon is a particle which constitutes light according to modern theory, and one photon interacts with the free electron of the metal, and then the electrons are ejected, known as photoelectrons, and the phenomenon is called photoelectric effect. So what is important to understand, that one term I have used, free electron. What is this free electron? In current electricity, you have understood that free electrons are those electrons, especially in case of your metal, large number of free electrons are present. If we talk about conductor, large number of free electrons are present. A substance is conductor because large number of free electrons are present. So what is free electron? Free electron is a type of valence electron which is free to move inside the lattice of the substance. Suppose if I am taking that there is a metal surface, this board is a metal surface, and one atom is here, then its free electron, that valence electron which is free to move inside the lattice of this metal, that will be constituting your free electron. So free electron basically helps us in understanding why a substance is a conductor. If we talk about bad conductor, then the number of free electrons is less. If we talk about insulator, ideal insulator we cannot say, then the number of free electrons is even very less. So a substance is an insulator because the number of electrons, there is no free electron, or the number of free electron is very much smaller, has a very much a smaller value, and ultimately it is not capable of conducting. So this is about free electron. Now we have talked E is equals to h nu. This basically tells the energy of one photon. In general, E is equals to n h nu, where n is your number. Any integral number is there. N cannot be fraction. If we talk about the energy of photon, or if we talk about the energy, suppose a question is there. E is not equal to how much? Here you see, here n is equals to 1, here n is equals to 1.5. So fraction n cannot be equal to 1.5. This should be clearly understood, that n cannot be equal to 1.5. So photon theory is very helpful in understanding the photoelectric effect. What is photoelectric effect? That yet now we have not discussed, but very soon we will be understanding it. The emission of electron, you know that flow of charge constitutes your electric current, and electron has charge. So if the electron is flowing or coming out of a metal surface, naturally some sort of current is developed, and that current will be called as photoelectric current. What I would like to tell you, suppose here is a metal surface. Why I am taking metal? Because in case of metal, large number of free electrons are available, and if the large number of free electrons are available, we can easily observe the phenomenon of photoelectric effect, and best metal is your cesium. Why? We will be discussing. Alkali metal gives the phenomenon of photoelectric effect with visible light, and then in that cesium is the best suitable metal for your photoelectric effect. Now if the light is falling on it in the form of photons, light is falling on this metal surface in the form of photons, then here the electrons are ejected. And when electrons are ejected, this phenomenon is called photoelectric effect. And this ejected electrons are called photoelectrons. This is basically your photoelectric effect. This photoelectric effect phenomenon was explained by Einstein in the year 1905. In the year 1905, Einstein gave a very good explanation, a very satisfactory explanation of the phenomenon of photoelectric effect, on account of which he was awarded with Nobel Prize in 1921. Now you should understand it very carefully, that you should know that Nobel Prize is not given posthumously. That means after death it is not given. Before death only, the Nobel Prize, it is the custom that is being followed by the authorities in giving the Nobel Prize. So Einstein gave the explanation. Einstein did not get the Nobel Prize for his theory of relativity, but he got the Nobel Prize in 1921 due to his successful explanation of the phenomenon of photoelectric effect in the year 1905. So this was the small brief introduction of photoelectric effect, that when light of suitable frequency, any light cannot cause your photoelectric effect. Any light is falling and that will cause photoelectric effect. This is not like that. Light of suitable frequency, what is that suitable frequency? That also I will discuss with you. Light of suitable frequency, when falls on the metal surface, then electrons are ejected, electrons are emitted, and this phenomenon is called your photoelectric effect, as I told you. One thing also you should understand, that this frequency can be written as E is equals to hc by lambda, where c is the speed of light and lambda is the wavelength associated with light. Now E by c, this gives the momentum of photon, that is h by lambda. So this also you should remember, that momentum of photon is given by h by lambda. So a very important result is waiting for we people to understand, that E is proportional to 1 by lambda and P is proportional to 1 by lambda. Energy of incident light, energy of light is also proportional to 1 by lambda, and momentum is also proportional to 1 by lambda. So if we increase the wavelength of light, if wavelength of light is increased, naturally energy is going to decrease and momentum of photon is also going to decrease. Similar manner, if the wavelength is decreased, then energy is also going to increase and momentum is also going to increase. You should understand it very carefully, that this type of simple relations, simple conceptual problems are being frequently asked in your entrance examination. So this type of conceptual question will certainly help you in building a better confidence on the subject matter. Now see this relation. E is equals to hc by lambda. H is your constant. If you will calculate the value of product hc, naturally it will be a constant, and if we measure the energy in electron volt, then this will give you electric energy of radiation, energy of photon will be certainly equal to 1 to 4 to, if you multiply, this will be coming in electron volt, or sometimes we take it as approximately 1240 by lambda. In terms of angstrom, if you will take it, energy will be this much electron volt. So if the question is being asked that the average wavelength of light is suppose 500 nanometer, what is the energy of photon? The photon that is falling has the wavelength of 500 nanometer. Then what is the energy of photon in electron volt? Naturally, E in electron volt will have the relation E will have the value 2.48 electron volt. That means a light of wavelength 500 nanometer has the energy 2.48 electron volt. we can easily find the energy in electron volt if wavelength is given. Now we have understood what is photoelectric effect, what is photoelectron. So this matter you all should understand very carefully, and it will help you in understanding the photoelectric effect somehow in a better way. So let us now try to understand few things that will further clarify the concept of photoelectric effect. Just now we have seen E is equals to h nu, frequency. Energy of photon is equals to h nu. Now if you see the visual, in this direction wavelength increases, and in this direction frequency increases. Here red has the maximum wavelength and violet has the maximum frequency. Energy is proportional to frequency. So frequency of violet is greater than frequency of red. Hence, energy of violet is greater than energy of red. That means if the comparative statement is there to find that whether red photon has more energy or violet photon has more energy, you can understand very carefully and you can give the answer very confidently that violet has more energy in comparison to red color photon. This will also help you in understanding or in solving many questions. Now, when we are talking about the photoelectric effect on a metal surface, the energy is sufficient enough to release this electron. Now, if the incident light that is falling or the photon that is falling does not have the energy to that sufficient extent, then this phenomenon of photoelectric effect will not take place. Suppose 10 joule of energy or 10 electron volt of energy is required to release this electron, and the energy of this photon is less than 10 electron volt, then naturally this energy will not be sufficient to release the electron from the metal surface. So whenever we are talking about a sufficient energy, that means a sufficient value of frequency. So here we have to define the two terms. One is called terms need to be understood very carefully. One is threshold frequency and one is threshold wavelength. Threshold tells about limiting value. Threshold tells about the limiting value. It can be maximum or minimum. If we talk in terms of frequency, it is that threshold frequency, is that minimum value of frequency which is capable in liberating the electron from the metal surface. minimum value of energy, because this electron needs certain amount of minimum energy. For minimum energy, frequency should be minimum, and that specific minimum value of frequency is known as threshold frequency. You know that frequency has the inverse relationship with the wavelength. So naturally, if frequency is minimum, wavelength is maximum. So whenever we are talking about the frequency or wavelength of the incident radiation, frequency should be greater than a minimum value. That minimum value is called threshold frequency, and wavelength should be less than a minimum value. Maximum value, wavelength should be less than a maximum value, and that maximum value is called threshold wavelength. So threshold wavelength is maximum and threshold frequency is minimum. Threshold frequency is minimum of the value of frequency above which, including that, photoelectric emission is possible. What does it mean? If I suppose for a certain metal, green is the threshold frequency. If green is the threshold frequency, then you see this blue, indigo and violet has the frequency more than the green. So the photoelectric effect is possible with green, blue, indigo and violet. At the same time, if you want to talk in terms of wavelength, then wavelength of this is maximum. This maximum wavelength has the capability to produce photoelectrons, and less than this value, maximum value of wavelength less than this value is sufficient to produce your photoelectric effect. So two terms needs to be understood very carefully. One is your threshold wavelength, threshold frequency and threshold wavelength. Threshold wavelength is maximum value of wavelength. That means for photoelectric effect to take place, what is required? Wavelength should be less than the maximum value. If wavelength is less than the maximum value, threshold value, you will get photoelectric effect. If we talk in terms of frequency, frequency should be greater than the minimum value. Frequency should be greater than the minimum value, that is your threshold value. In such situation, this is the same thing said in two different way. If we say wavelength maximum, that means frequency minimum. Meaning remains the same, only mode of saying or the way we say is only different. Same matter we are representing in two different way. In one way we are saying threshold frequency, in another way we are saying threshold wavelength. So threshold wavelength is the maximum value of wavelength below which the photoelectric effect is possible, and threshold frequency is the minimum value of frequency above which the photoelectric effect is possible. Photoelectrons are ejected by the metal. So dear students, we have to explain the next term, that is your work function. In the process of discussion of work function, as I have already told you that here is the metal surface, and in the metal surface the photons are falling and the electrons are emitted. It contains, metal is there, it contains large number of free electrons. Now you see, suppose in order to eject this electron, we need 10 electron volt of energy. Certain amount of energy is required in order to eject this electron with the help of light, that is the photon here. If the energy of photon here is 5 electron volt, you can understand very well that this energy of photon is not sufficient to eject the electron from the metal surface. So what we have to understand, certainly the energy of photon should be greater than equal to 10 electron volt. If the energy of photon is greater than equal to 10 electron volt, which is required for liberating this electron from the metal surface, then only we can expect the photoelectric effect. That is very important to understand. So the energy of photon that we are taking is h nu. It performs two tasks. First portion, here you see, if I taking this energy level diagram, here is the surface. This portion of energy, the energy that is coming, this portion of energy brings the electron here on the surface. So this is your work function, phi naught. And rest portion of the energy, if it is greater than the minimum energy, that is work function, will give the kinetic energy to the electron. Now it is not essential that the energy will always give this much amount of kinetic energy. It may give this amount of kinetic energy, this amount of kinetic energy, or even this amount of kinetic energy. Here you see. So the kinetic energy of the electron varies from the region. Kinetic energy of electron varies from the region. It is between 0 and Ke max. The kinetic energy of electron that is liberated is varying from 0 to Ke max. So the two portions of this energy, one portion is used to bring the photoelectron at the surface, and other portion provides the kinetic energy. So here you should understand that this portion which brings the photoelectron on the surface and makes it capable of liberating the surface, ejecting from the surface, that portion of energy is known as your work function. Whereas the other portion of energy is used in maintaining the kinetic energy of electron. So what is important? Therefore, if we want to define the work function phi naught, work function is that minimum amount of energy which is required to liberate the electron from the metal surface. So work function is that minimum amount of energy which is required to liberate the electron from its metal surface. So work function, one more thing you should understand, that this work function is not the property of photon. It is not depending on the photon. This work function depends upon the nature of material. This work function depends upon the nature of material of metal. What is the nature of material? If different metals are there, A, B, C, D, then the work function, different metals have different, and we can say phi A for work function for metal A, phi B work function for metal B, phi C work function for metal C, phi D work function for metal D, like that only. So work function is that minimum amount of energy which is required to make the electron capable of leaving the metal surface. This is the work function. Now, after understanding the work function phi naught, what is other important fact that you should know is the Einstein's photoelectric equation. If we want to understand the Einstein's photoelectric equation, so the energy of electron has two parts. The energy of photon that we are getting is used in two ways. One for work function and other portion is providing the kinetic energy to the electron. This value can have other forms also. You should understand very carefully that this is all the three equations are Einstein's photoelectric equation, in which this nu naught represents the threshold frequency, this lambda naught represents the threshold wavelength, and this is your Ke max. This equation is also very useful in solving the problems of photoelectric effect. So up till now, what we have understood? We have understood first, what is photoelectric effect? Second, what is threshold frequency? Third, what is threshold wavelength? Fourth, what is work function? And fifth, what is Einstein's photoelectric equation? Hope that this much amount of discussion on the basic fundamental concept of photoelectric effect certainly make you confident in understanding the concept of photoelectric effect. In my next class, I will explain the photoelectric effect, what is the experimental arrangement, and what is the graphs related with the photoelectric effect. So thank you. Have a nice day.